For week 7, we continue our lecture for topic chapter 5. It's about derivative of carboxylic acid. Previously, we studied about the introduction of carboxylic acid. So now, we learn and elaborate more about the derivative of carboxylic acid. So here is the lesson outcome from this chapter. Okay, so look at the introduction. For the nomenclature of the carboxylic compounds and derivative. Okay, for your information, acyl group is bonded to Y, which is Y is electronegative atom or living group. So Y it could be halide, acid halide, or acyl oxy anhydride, alkoxy, ester, amine, amide, thiolate, thioester, phosphate for acyl phosphate. So here is some of the example for acyl group, which is a carboxylic compound and its derivative. It's depend on the Y attached on the acyl group. Okay, so this one we call as acyl group. RC double bond O is acyl group, and then bonded to any of Y. So Y it could be OH, we call as the carboxylic acid, and then RC double bond O this is acyl attached to the X could be halide, chloro, bromo, iodo, and fluoro, acid anhydride for this one. Ester, Y is OR, and then amide is RC double bond O attached to NH2, and then thioester, RC double bond O attached and or bonded to SR, and this one is acyl phosphate. So all of these are example of carboxylic compounds together with derivative. So here is the carboxylic acid derivative, okay, which is halogen, Cl, bromo, chloro, bromo, iodo, and fluoro. Okay, name of the compound we call as acid chloride or acid chloride. So here is general formula for acid chloride. Okay, acyl bonded with the halogen, any type of halogen. So for this one, we focus for chloro, so it become acyl chloride. Okay, RC double bond O is acyl attached with halide, we choose as chloride. So that's why the name for this general formula is acyl chloride, or we call as acid chloride. Acyl/acid. Okay, so if group replacing with OR, it means O attached with alkyl, so name of compound is ester. So this is a general formula for ester, RC double bond O, OR. So any kind of alkyl group attached O and then bonded with acyl group, so we call as ester, followed by NH2, okay, functional group NH2, and name of compound is amide because of from this general formula RC double bond O bonded with amide. For this one, acid anhydride. Why acid anhydride? Because of there are two acyl group and then join together with O. So this one is acyl O and join with acyl. So that's why the name is acid anhydride. So look at the naming or nomenclature. Okay, first one is acid chloride. This is first derivative for carboxylic acid, acid chloride. So general formula, please memorize RC double bond O, acyl attached with halide. So halide, we choose chlorine as a halide attached on the acyl group. So IUPAC's name is become replacing oleic acid to YL chloride. So from the name carboxylic acid is ethanoic acid. Okay, after OH functional group replaced with Cl, so the name become ethanoyl chloride. So this one ethanoyl from the group acyl and chloride is X. So name for this compound is ethanoyl chloride. So carbonyl carbon atom is designated as C1. For this case, acid chloride, so carbonyl carbon is designated as C1. Look at for the carbonyl group in the acid chloride. So example for this one, okay, C double bond O, and then the nearest is Cl halide, so it become this one C double bond O become designated C1, and then followed with the nearest carbon C1, C2, C3, C4 and C5. Okay, so here is some of example for acid chloride. Okay, acid chloride named as alkene carboxylic acid if the acid chloride suffix is carbonyl chloride. So it mean this carbonyl attached with the cyclic and bonded with Cl. So name become cyclic first and followed by the parent name. So the parent name is carbonyl chloride. Okay, carbonyl attached with chloride and then together with cyclic. So for this carboxylic acid, or this one for acid chloride, so they have a common name. So example for this one, so 1, 2, 3, so propanoyl chloride is IUPAC name, but it have a common name for propionic chloride, which is a propionyl chloride. Okay, common name for this propanoyl chloride we call as propionyl chloride. Okay, number 2 is acid anhydride. Okay, acid anhydride, so word acid in carboxylic acid we substitute or we replace with anhydride. Okay, so example here, ethanoic acid. Ethanoic acid is IUPAC name for acid carboxylic acid, and then once this acyl group, okay, attach O and then attach with acyl group, so the name become ethanoic anhydride. Okay, so if this one, only this one, so we call, and this one is OH, we call as ethanoic acid. Okay, once this acyl group attached with O, attached with acyl group, so the name become ethanoic anhydride. Okay, same to this one. So if the anhydride composed of two different acids, so called mixed anhydrides. Okay, for example, for this one, naming by citing the two acids alphabetically and then adding anhydride. Okay, so here is acyl group and then attached with O and then bonded with C double bond OH. Okay, so there are two acid alphabetical here, so the name must be followed the alphabetical. Okay, parent name is anhydride because of there are two acyl group here. Okay, first because of this is ethanoic and this one is methanoic, so follow the alphabetical: ethanoic, methanoic, anhydride. So here is the common name. So this one example for the anhydride, acid anhydride. Acid anhydride. Anhydride means that the middle of the acyl group, between acyl group there are oxygen, attached by oxygen. Okay, third is ester. So according to the IUPAC system, so alcohol part of the ester we call as we allocate as the name first. Okay, so for example here, okay, this one is acyl group. Acyl group bonded with OR. Okay, OR, so the name become ethyl ethanoate. Okay, so this one is for ester. Ester parent name is become ADE, okay? Oic acid replaced with ADE, so it's become derivative of carboxylic acid, we call it as ester. So R, this one is refer for acyl group bonded with the OR, so the name become ethyl ethanoate, okay? Ethyl ethanoate. So here is some of example for ester. You can study and you can try to give for every compound name to understand for the ester nomenclature. So here is common name, okay? Common name for ester. Alcohol part is named first, derived from the common name of alcohol. So common name of ester derived by adding ADE to the name of the acid. Okay, so it means IUPAC name should be should be ethyl ethanoate for ester, but because of common name, so name is become ethyl acetate. Ethyl acetate from the your experiment, your lab, and the common name is always used compared to the IUPAC name. So for amide, okay, amide is the next derivative of carboxylic acid. Okay, IUPAC name primary amide. Okay, primary amide, drop the oic acid and add with the suffix amide. Okay, so carbon is designated as carbon 1. So example here, C double bond O, so this one is acyl group attached with OH, so this one is carboxylic acid. Okay, so IUPAC name ethanoic acid. Okay, but for amide, acyl group bonded with NH2, which is amine, so the name is become ethanamide. Okay, for this one is for common name. Okay, carboxylic acid, IUPAC name ethanoic acid. Once common name, it become acetic acid. So for ethanamide, so common name is become acetamide. So here is example for amide. You can study and you can learn more about the amide naming or nomenclature. Okay, so this one is for secondary and tertiary amide. Okay, it means alkyl group on nitrogen, okay, on nitrogen as substituent. Okay, it means here and or alkyl group on nitrogen as substituent, on nitrogen as substituent. Okay, so specify their position by the prefix N. Example for this one is acyl group attached with N. Okay, for secondary amide, so this one 1H and this one is 1R, so we classify as secondary amide. Okay, so this one is IUPAC name and ethyl ethanamide. Okay, and ethyl ethanamide. Okay, for this one, because of both of proton on nitrogen filled with the alkyl group, so they are specify their position by the prefix N. So it's become N-ethyl, okay, follow the alphabetical, N-ethyl, N-methyl ethanamide. Okay, so here is some of example nomenclature for secondary and tertiary amide. Okay, this one is secondary amide and this one is tertiary amide. Okay, for amide, if you look here, okay, C double bond O and H2 amide. Amide, there are 2 proton on nitrogen, but for secondary there are 1 proton on the nitrogen. Okay, for tertiary there are 2 proton, there are 2 R on nitrogen. Okay, so please correct for this one. Okay. For acid that are named as alkane carboxylic acid or suffix name is become carboxamide. Okay, so this one is for cyclic. Okay, alkyl group attached to C double bond O, which is cyclic attached C double bond O bonded with the amide. So name is become cyclopentane carboxamide. Okay, so it's different for the cyclic compound. Okay, which is acyl group attached with the NH2, so the name is become cyclopentane carboxamide. So here is the acyl functional group interconvention. Okay, is just a briefing about nucleophilic acid acyl substitution. Okay, from the chapter 2, we study about the nucleophilic substitution. Okay, so now we focus on nucleophilic acyl substitution reaction. Okay, because of there are many acyl group, and from the acyl group bonded any type of functional group, so produce derivative of carboxylic acid. So this is a general reaction for the nucleophilic acyl substitution reaction. Okay, look at this. Acyl group attached with Y. Y is depends on the functional group, react with any kind of nucleophile, and then from the basic for the nucleophilic substitution, this nucleophile must be strong nucleophile and then attack on this carbon, because this carbon contain of high density electrophilic. So nucleophile attack with this electrophilic, so remain on the carbon, and then side product must be leaving group. Okay, so mostly carboxylic acid and their derivative react with the nucleophilic acyl substitution. Okay, so nucleophile form a new bond with nucleophile side, and the leaving group Y detach from the molecule. Okay, detach it mean remove from the molecule. Okay, but for the nucleophile form a new bond with the C double bond O, and Y detach or remove from the C double bond O. So that is basic for the nucleophilic substitution acyl reaction. So addition-elimination mechanism of nucleophilic acyl substitution in basic condition. So please memorize for this basic rule. Okay, addition, you add and eliminate process. Okay, nucleophile add on carbonyl. This is a first step to form intermediate in tetrahedral, and then leaving group expel or detach. Okay, or remove to generate new carbonyl compound, so leading to substitution. Okay, so this one is step 1, nucleophile attack on carbonyl carbon. Okay, so pi bond will cleave. Okay, once react with nucleophile, so what happen, this nucleophile attack on this carbonyl carbon, so pi bond cleave, and then so it's form new bonding, nucleophile form new bonding with C. And for the step 2 elimination of the leaving group, we eliminate the leaving group, or we detach leaving group. Okay, after step 1. Okay, here is the mechanism. Nucleophile attack C carbonyl, C double bond O, and then pi bond. Okay, pi bond will cleave after to form the intermediate. Okay, so attack here and cleave, pi bond cleave, and then it's become intermediate O minus. So this one will be leave from C and produce product and leaving group. So this one is a basic. So here is a relative reactivities of carboxylic acid derivative towards nucleophilic acid substitution reaction.